Here we are with Unit 6, Lesson 7, Observing Morse Patterns and Scatter Plots. For your first problem, we're talking about literacy rate and population for 12 countries with more than 100 million people are shown in a scatter plot. We are supposed to circle any clusters in the data. Remember, a cluster is just simply a group of data that are just grouped together. So we see, obviously, there's a cluster right here. You might be thinking, what about these two out here? Well, they can't be a cluster. They're too far apart. Don't circle those. So now what are you going to do for your work for this one is you're going to take a screen capture of just that graph right there. And then your job is to go and write on it somehow like this, and then upload that picture to this problem where it says that you have the option. It says if you don't have any way or ability to upload, that's not true because you all have the Chromebook. That is not an option for you. Your picture needs to be uploaded in this box. Find the other cluster on there because there's another one. This one, we're going to make some analysis of this scatter plot. And so here's a scatter plot. Your job is to select all the following that describe the association in the scatter plot. There's really two major associations that we're looking for. We are looking for associations that tell us whether our data are linear or nonlinear. Now, obviously, a scatter plot can never be exactly linear, or else we'd call it a linear equation. But we call this a linear association, meaning that the data are generally, I guess I'll try this again. Are generally linear. That's for this one right here. Then obviously nonlinear association means that the data are not linear at all. There's no comprehension of a pattern to them at all. So in this part of it, the first two options, you'll pick one of those as the correct option. And then you look at the next part of it. Is there a positive, negative, or no association? So looking back at these data, when you read these data from left to right, are we looking at data that have a positive association, meaning as age increases, weight increases? Is there a negative association? As weeks increase, the weight decreases? Or is there no association, meaning that the age has nothing to do with the weight of whatever this is? So pick one from the top two choices and one from the bottom three choices. You should have 2 check marks, and that's it for this one. For the next problem, we have for the same data, 2 different models of graphs. So we have graph A and graph B. And what we did here, what they did for us is they graphed a line of fit in 2 different places. We're saying which model more closely matches the data. So we have the piece that we just talked about, the line of fit. But there's one more thing out there. We're looking for the best line of fit, meaning the one that more appropriately or most appropriately represents the majority of the data. All I would tell you with this is think about a hot dog. Think about these data and how did you do with putting your hot dog right in the middle of the bun. Select which model you believe is the best. Tell me exactly why. Please don't talk about hot dog in your explanation, but please talk about what that best line of fit represents and why it should be placed where it was. Skip over that problem, then we get to the last one that talks about the volume. Now, when we're working with this problem, we have to consider the fact that volume of a cone is 1/3 the volume of a cylinder. So we have the area of the base, pi r squared, and then we have the height. We want to multiply by 1/3 because that's where we're at. It's 1/3 the size of a cylinder, the same values. What we know about this cone is that the volume is V. So let's go and write this one in blue. We know the value of the volume is V. We know that the radius continues to be r, so it's still r squared. And we know the height is 12. That leaves us with 1/3 times pi as numerical values that will not change. This is where we start with this, and what we should do with this is we should simplify to understand that the volume is equal to 1/3. So this part 1/3 in the 12 is equal to 4 times pi times the radius squared. So that's the only thing we know about the volume of this figure. Now, what we're doing with this next part is it says that we're going to take a cone that has the same height and 1/3 of the radius. So the only thing that's changing here, or the thing that's going to change the volume, is we're going to take 1/3 of the radius. So at this point, we know that the total volume for this cone, the only difference is the height. So we could go back through and look at this whole situation and go back to this, where we see that 1/3 times pi times the radius squared times the height of 12. Or we can work from the simplified version, which I think the simplified version would be a simpler way to do this. And what we're going to do with this is the volume still equal to 4 times pi, but the radius will be 1/3 of what it was. You'll notice that I put 1/3 of r in parentheses. That means 1/3 of the radius will be squared. So now after we simplify with that exponent, we have 4 times pi. The r squared is still the same thing, but I'm going to pull this part out where now we have 1/3 to the second power, which actually ends up giving us this. That's the only change that's going to happen, is instead of multiplying by a value that's there of 1/3, we actually have to square that value, giving us 1/9. That squares the numerator and the denominator, 1 to the second power and 3 to the second power. So really, the only thing that we're seeing change right here is just taking 1/9 of the rest of the volume. We can look at that volume right here. This was the initial value, and then we take 1/9 of it. So the value right here, when we talk about writing an expression for the new volume, we're talking about that volume V was equal to this value, but by multiplying by 1/9, I'm getting 1/9 of that volume. Or the best thing that we can say with this, since it's an expression, 1/9 of V is simply volume divided by 9. This would be the expression that we want right here. Now it says a cone has the same height and 3 times the radius of the original cone. Write an expression for its volume. Well, we need to think about this. When we're talking about before, it was 1/3, and we multiplied by 1/3 squared, which was ultimately multiplying by 9, or 1/9. So we divided by 9. What does that mean that we do right here with 3 times the radius? I'm going to leave that one for you to think about. On that note, I'm going to end the video. Please email me or check in with me if you're still struggling or have questions on any of these. You're doing a fabulous job. I hope you have a great day.